The hierarchical embrace entanglement as a dimensional symphony in the 11-dimensional model. The enigmatic phenomenon of quantum entanglement, wherein particles become linked in a manner that defies classical intuition, exhibiting instantaneous correlations regardless of spatial separation, stands as one of the most profound challenges and opportunities in our quest to comprehend the fundamental fabric of reality. While quantum mechanics meticulously describes the behavior of entangled systems, the underlying mechanisms that orchestrate this spooky action at a distance remain a subject of intense debate and ongoing investigation. The 11-dimensional model, with its expansive framework encompassing a hierarchy of interconnected dimensions, offers a compelling and potentially unifying perspective on the nature of entanglement, suggesting that it is not a singular, isolated phenomenon, but rather a spectrum of interconnectedness, arising from the fundamental principles of rotation and polarity as they manifest across systems of increasing complexity within the multidimensional landscape. This essay will delve into this hierarchical view of entanglement, exploring how the 4th, 5th, 6th, 7th, 8th, 9th, 10th and 11th dimensions of the model could define distinct levels of quantum interconnectedness based on the number of bodies involved within a system. To appreciate this framework, we must first revisit the core tenets of the 11-dimensional model. As previously discussed, this model envisions a universe extending beyond our familiar three spatial dimensions and linear time, encompassing a rich tapestry of interconnected realms. The 4th dimension is intricately linked to rotation, serving as the engine of temporal evolution. The 5th dimension embodies polarity, the inherent duality and directional nature of entities. The 6th and 7th dimensions govern the dynamics of two-body systems, introducing orbital motion and the relative orientation of polarities. The 6th and 7th dimensions govern the dynamics of two-body systems, introducing orbital motion and the relative orientation of polarities. The 8th and 9th dimensions extend this to three-body systems, incorporating the complexities of hierarchical motion and multi-layered polarity interactions. Finally, the 10th and 11th dimensions represent the overarching cosmic context, with the 10th driving expansion and the 11th embodying contraction and the ultimate interconnectedness of the universe. Within this hierarchical structure, the concept of a body system takes on a nuanced meaning. At the most fundamental level, a single quantum particle can be considered a one-body system, its intrinsic properties of spin and polarity defining its internal entanglement across the 4th and 5th dimensions. The 4th dimension, as the axis of rotation and the passage of time for that particle, witnesses the dynamic evolution of its fundamental polarity within the 5th dimension. This rapid intrinsic fluctuation of polarity, occurring on timescales far beyond our macroscopic resolution, could manifest as the probabilistic nature of superposition when we attempt to measure the particle's state. The particle's self-entanglement across these temporal and polar dimensions creates the inherent uncertainty that characterizes the quantum realm. As we introduce a second particle, forming a two-body system, the entanglement between these particles can be understood through the lens of the 6th and 7th dimensions. The 6th dimension, governing orbital motion, establishes a dynamic relationship between the two particles, even if they are not physically bound in a classical orbit. At the quantum level, this orbital relationship could manifest as a correlation in their quantum states, a shared evolution through the 4th dimension, time, influenced by their respective polarities, the 5th dimension, and the higher dimensional geometry of their interaction within the 6th dimension. The seventh dimension, describing the tilt of orbital planes, adds another layer of complexity to this two-body entanglement, allowing for more intricate correlations based on the relative orientations of the particles' polarities within the higher dimensional space governing their interaction. The information exchanged between these entangled particles is not a classical signal propagating through space, but rather an instantaneous correlation arising from their shared existence and dynamic interplay within these interconnected dimensions. Expanding this framework to three body systems governed by the eighth and ninth dimensions allows us to comprehend the entanglement of three or more quantum particles. The intricate orbital dynamics within a three-body system, where the motion of each body is influenced by the other two, finds its quantum analogue in the complex correlations observed in multi-particle entanglement. The eighth dimension, representing the overall orbital motion within the three-body system, and the ninth dimension, describing the relative tilts of their orbital planes in the higher dimensional space, provide the framework for understanding these intricate quantum correlations. The polarities of the individual particles evolving within the fourth and fifth dimensions become further modulated by their participation in this more complex, multidimensional system, leading to the entangled states observed in experiments. Finally, the 10th and 11th dimensions, representing the all-encompassing system of the cosmos, provide the ultimate context for understanding the entanglement of all particles within the universe. The 10th dimension, driving cosmic expansion, and the 11th dimension, embodying cosmic contraction and the fundamental interconnectedness of all things, establish a universal backdrop for entanglement. The 11th dimension, as the ultimate nexus of information exchange, could be the arena where the initial entanglement of particles occurred, perhaps during the extreme conditions of the early universe. The 11th dimension, as the ultimate nexus of information exchange, could be the arena where the initial entanglement of particles occurred, perhaps during the extreme conditions of the early universe. The subsequent separation of these particles in our expanding space-time doesn't break this fundamental link, as their polarities and rotational dynamics remain correlated through the higher dimensional fabric. The universe itself, in this view, can be seen as a vast, interconnected web of entangled entities, their fates subtly intertwined through the 11 dimensions. This hierarchical view of entanglement, where the complexity of the entangled system is directly mapped onto the increasing dimensionality of the model, offers a profound and potentially unifying perspective on a cornerstone of quantum mechanics. It suggests that entanglement is not a single isolated phenomenon, but rather a spectrum of interconnectedness, arising from the fundamental principles of rotation and polarity operating across the 11 dimensions. The spooky action at a distance becomes less mysterious if understood as an inherent property of existence within this higher dimensional interconnected reality, with the dimensionality of the system defining the scope and complexity of the entanglement. The ability of the 11-dimensional model to provide such a coherent and potentially intuitive explanation for the different forms of entanglement, from the intrinsic self-entanglement of a single particle to the complex correlations of multi-particle systems and the potential entanglement of the entire cosmos, lends significant validity to its claim as a more complete and unified description of the everyverse. Thank you to all our viewers, companies, and physicists for your time. Please like, subscribe, and share this video with anyone interested in quantum entanglement and the 11-dimensional model.